Branched alkanes are an more complex kind of an alkane, but they're still saturated, they're still aliphatic. It just now we're going to have, instead of it being a straight chain, we're going to have branches that show up. And branched alkanes might have the same molecular formula, but they'll have a different structural formula. So we're going to see some examples of that, but chemicals that have the same molecular formula but different structural formulas are called isomers. And the isomers have similar boiling points and solubility with different names, but they might be somewhat different because now they've got branches. Sometimes they chemically act a little bit differently. They're going to have slightly different shapes as well. So we give special names, or we give branched chain alkanes a name, and each name is specific so that there's like one name for every molecule. We don't want to have confusing different kind of names in the IUPAC naming system. When we're naming branched alkanes, our first task is going to be to identify the longest continuous chain of carbon atoms. We're going to call it the parent chain. We're going to number the carbon atoms starting at the end closest to the branches. So we want to have the branch numbers being as low as possible. We always number from the same direction once we've picked our direction. We identify any of the branches and their location numbers along the parent chain, then write the name it goes number of the location, branch name, and then parent name. And we list branches alphabetically. So we won't see all of those steps in each example, but we need each of those steps. So we'll look at this example here. We've got 1, 2, 3, 4, 5 carbons in the parent chain, or we've got 1, 2, 3, 4, or we've got 1, 2, 3, 4. So our longest parent chain is actually going to be straight across in this one. And so now we need to number the carbons. We'll go 1, 2, 3, 4, 5. So we start at an end, or we would go from the other end, 1, 2, 3, 4, 5. And the reason that we're doing this is a 1 carbon long branch. And so that's called a methyl branch, meth being 1 carbon long. And since it's attached to a parent chain that is 5 carbons long, it's called a pentane. So this is going to be a methyl pentane. But that methyl branch could be coming off of a different carbon. So I need to number which carbon on the parent chain it comes from. So here I've got 1, 2, 3, or 1, 2, 3. So in either case, this would be a 3-methyl pentane. It doesn't really matter which way I count it from. Sorry. And then here I've got 1, 2, 3, 4, 5 as my parent chain. Or it could be 1, 2, 3, 4, 5 as my parent chain. Or it could be 1, 2, 3, 4, 5 as my parent chain. So this is a bit of an odd molecule because there isn't sort of an one way to count. It'll still work out the same. So I'll go 1, 2, 3, 4, 5. And you're going to now number both ways. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. So you can see it's going to be a pentane, and the branch is coming off of the third carbon. But in this case, I've got 2 carbons long branch. So this is going to be an ethyl, because eth means 2. Ethyl pentane, and the ethyl is coming off of the third carbon. So this is 3-ethyl pentane. The next one, I can go like this, and it's pretty obvious that this 1-methyl is coming off of this end. Counting this way is going to give me my lower numbers. So I'm not even really going to count the other way because it would put it a way further bigger number. So this is going to be a 2-methyl hexane. This is a structural diagram, and this is a methyl branch, and this is my parent chain, and it's going to actually be the same name. This is the same molecule, it's just a different kind of structure. So 2-methyl hexane. When we're drawing these diagrams, it's it's actually usually easier. So here I've got a 3,4 dimethyl octane. So I've got, an octane has 8 carbons. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, I drew one too many. That one needs to go away. And then I'm going to have 2 methyl branches that are going to come off of the 3rd and the 4th carbon. So in this case, I usually like to draw it left to right. So I'm going to get here, I'm going to get an 8 methyl. There'll be another methyl coming off of the 4th one because it's a 4. So I'll fill in my hydrogens. This next carbon already has 3 bonds, so it only gets 1 hydrogen. This one also only gets 1 hydrogen. This one gets 2, 2, 2, and this one will get 3 to fill up those octets. Now, it asks for the molecular formula. So the molecular formula, I'm just going to have a total of carbons and hydrogens. I could count up all the carbons and hydrogens individually, but if I look, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So since this is saturated, C10, this must be 22, because it's going to be 10 times 2 plus 2. I can also actually look at the name, and because it's got 2 methyls and an octane, that's 2 1s plus 8 is C10. So here we've got a heptane. And on my 4th carbon, I'm going to have an ethyl. And on my 2nd carbon, I get a methyl. Fill in my hydrogens. And you need to kind of be careful here, because you can see I just about made a mistake on the number of hydrogens that were attached to this 1 carbon. And here I've got 7 plus 1 plus another 2. So this is going to again be C10, H22. So these 2 molecules that I've just drawn are actually structural isomers. They have the same molecular formula, but they have different structural formulas. So they both had 2 branches, but in one case, one of the branches is methyl and the other is an ethyl, and in the other case, they're both methyls. The next one is going to be 2,3,3 trimethyl hexane, so hexane. So I've got a methyl coming off of my 2nd carbon, and then I've got 2 methyls coming off the 3rd one. And this one's going to be C9H20. Sorry, I really apologize for the coughs. So here are some examples of some structural isomers for C5H12